So it's been a while since I've made a hardware project, and a Raspberry Pi camera is a pretty cliche one, but this one is like a unique design, kind of like quirky on purpose. So this is the ML Hat cam, which I don't say it failed, but I'm not like gonna strap that thing to my head again and we're messing around with it. Future version will be like a tripod. So I will take the display from here, because I thought I bought more than one. I had briefly considered using this, like a super tiny OLED, but it's only white. Like, it's not a RGB, so that won't work. What I want it for is to be able to check if a photo is in focus by like zooming in part of a picture like a real camera does, and you use the buttons. So we'll have an interface like this, probably this on the right side, and then it'll be a Pi Zero. This is a DC-DC boost converter, so it'll step up the 3.7 volt to 5. I could use one of these, but I wouldn't mind if the camera lasted a while. So yeah, this is pretty much just designing a body with all the parts in there, a switch, and then the display and D-pad. I also have this, which is like a full Pi. The problem is, like, this is way too big. I don't want that. It seems like it would make sense, but I like this idea of a tiny one. And then both of these are like way too dim, unfortunately, to be seen outside. So that's like a issue from the get-go. One of these lenses doesn't really work well. Like it's not possible to focus it unless you have it barely screwed in. So once I remember which one it is, it won't be in here, but I might have two lenses. This is the primary one. Can't remember what the millimeter is on it. Yeah. So that'll just be a fun little project. This is super jank. Filming with like a giant headlamp squeezed against the NEX5N. Anyway, so this is what I've come up with at this time. The hardware layout will be like this. It's going to be like a long rectangle, long-ish. It was much longer, but I went with these batteries instead of the long cylinder one. So these will go somewhere. This has to go somewhere too, maybe on top or on bottom. Anyway, there'll be a BMS that both those batteries are connected to. It's a single cell. It's parallel, so it's just like double capacity. The Pi is like this because the SD card, I didn't want to be able to get that out. I was trying to have it oriented the other way so the cables would come in from the top. You know, that potentially you'd get dirt in there, but... And then the D-pad stuff, it's gonna be, you know, on the right side like that, but I need like a way to go backwards, so I'll put another button up there, and there will be one for the shutter. And the D-pad is pretty much just, you know, it joins a circuit which goes into a GPIO pin, but when you look at it from the back, this is also a step-up power supply. It's just like 5 times as expensive as that one, because it's like super hardcore quality. And then this is a 3.3 volt step down linear regulator, so it drops the pins down to that level before they go into the GPIO pins. So yeah, now I just gotta design all these parts, align them, in 3D and CAD, give it enough room so the wires and stuff has room, and then put it together. I'll have to do some like test prints to make sure everything's like scaled right before I commit, because the prints take a long time. The halves will probably take like 5 hours each plus. Yeah, and these have to like get screwed in, be tight. These wires have to go into the GPIO pins. I'm probably just gonna put the male ones on, and then I'll make a board like with these that has all the buttons and everything wired. Whoops. And then it'll just stack on there like with a female mount, so it's easy to like take apart. I don't have to solder this pie into something. So yeah, it's just work. This is probably poorly lit, but you can, oh man, you can't see it. Well, if you look at the flowers, you can see it shifting around. But there's clearly a refresh line going through top to bottom. My frame rate is probably at 160. Let me try something else. Whoa, that's a 1/400. Oh, there we go. 160 is better. So yeah, you can see. Let me turn down the contrast. Yeah, so this is a photo taken from a Sony a7 II. It's a tiny crop shifting around. This is simulating like the live preview of the camera when it's looking at whatever you're going to take a picture of. The refresh rate is slow, and this is SPY, like this is the fastest. I don't know, maybe it could be even faster, but I'm not that hardcore of a like driver person. I just use the library. This is faster. I don't know, I'm not sure if it's faster. I saw somebody playing a video and it seemed fast, but the video quality was low, so maybe you can't see the refresh line like you can here. Okay, so here you can see how I'm estimating the body dimension based on where stuff will be. I soldered the board that connects to the Pi, and all the wiring goes there, so there's no, other than the power tap going to the back of the Pi under the USB, it's all going to be through the 40 pin header. This is old, but I'll have to make a new one. Same idea, but there will be a back button up here, and there will be a separate board for the shutter. And then there will be some room below for the IMU. This is a 6050 6-axis. And then the DC boost converter, they'll just be down there. This will get screwed to the back case. The camera's screwed to the front, and then there will be I'm not sure where this board will get connected to. The main alignment are the ports and the SD card slot, so the case will have that. And then yeah, everything gets wired. There will be a LD33V to drop the voltage down for the buttons for the GPIO pins, and I'll power the OLED with it. The OLED can run from the Pi, but like it's better to just have it separate, not pull from the pin. I'll have to solder everything and get it all working, but the body design, it's gonna take a while. Like once you design it, like printing that much material, each one will probably be like 5 to 7 hours, and there's 2 of them. Man, this thing is so nasty. God. See, this is a charging board, so the USB comes in as like a phone charger or like a computer. Computer, no, because it's like 1 amp. Phone charger, like on a wall. And then connects to the battery, which the over discharge is way too low, so I can't rely on that. Then there's a Y bridge from here, because it feeds the boost converter, and it also feeds the step down linear regulator, the LD33V. That's right there. 3.3 volts comes out of there. That'll feed the OLED and the buttons. It's just annoying to solder. If you look, that's the 10k ohm resistor. Tap to all of them. There's a switch, so it doesn't really matter if you go left or right on the button. It just has to get attached somewhere. And then the other pin goes to the GPIO of the Raspberry Pi, which picks that up as a high. High on is on, you know, like you clicked it. This is the little like proto board that's... Main reason this is here is so I don't have to solder to the Pi. So the OLED will get soldered here, wherever the pins are. That'll be fun. So yeah, I'm just soldering away, and then I'm going to have to write some code to check that everything's wired right. And then I'll finish designing the body. I'll print that like tomorrow. Might take longer. And then hopefully it'll be assembled, and then the rest is just programming. Oh my god, look at how many freaking wires there are. Jesus. Oh. So the first test is not good with the OLED. I've got the my schematic is flipped because of like yeah, this was dumb. Like you're looking at the back of the Pi, so this, you know, GPIO is like flipped when it mates with this. So like the blue pin is on that side. Wait, is it? Let me check. Yeah, so if you look at the wiring diagram here. Hey, look at that, you can zoom. I'm manually focusing. Blue is on the top, and I've got it on the bottom, so I haven't flipped. I gotta update those diagrams. I have to update it anyway because I went to single cell versus parallel. I got it working. I'll flip the things around. It's pretty neat. This is that $50 Chromebook. I'm just using the shell from Crush. But yeah, so that's working. Alright, so here it is, fully soldered together, powered on. Feel the heat coming off of it from the regulator. I got all the buttons wired up. Of course they're not doing anything, but you can see in the back they're all soldered together. God, it's so nasty. So I'm going to write some code to test that the buttons work, and then from here on I'll just realign this stuff, get outer dimensions again, make sure the stuff will fit, and then start positioning all the screw holes and whatnot. And then I'll design the body. It'll have like slide rails. You can see it over here. So when you join the two halves together, the screws will go down into them. That's what will keep it together. And I am going to use glue. I was going to screw the stuff together, but like this button here, there's only one screw hole. You know, you could drill one of these holes out, but I'm just going to glue it. First try, baby, let's go! I don't have the D-pad wired yet. Or sorry, not D-pad. The OLED display where I can write text to it and all that with code. But you can see here, like I'll click shutter. Shutter. And then I'll do back, left, center, right, up, down. Cool. Oh, I forgot to wire the IMU. It's not hard, it's just 4 wires, but oh man, how did I forget? Alright, so we've got the battery charger thing right there, micro USB battery. We've got the IMU, that's a 6050 6-axis, gives you a accelerometer and gyro. Gyro's the thing you use for the horizon level, as well as acceleration, like if you have 9G gravity, or not 9G, 1G, DC-DC boost. This is the proto board that's connected to the Pi GPIO, 40-pin header, D-pad, shutter, OLED. That's just missing the ribbon cable to go to the camera, flat connector. So I've come up with a design for the lens system, like a normal camera. Unfortunately, the various lenses that I have, the 5 and the 12mm, their zoom is not working. But I'll still add that ring layer on. So the body will have this base that has these notches to grip into. That's your sensor board right there. And then the ring layers will get these clamps. You can see here, it's like a split. So it goes around the ring, then you put a screw in to tighten it. And then that, is snug against there, so it's resistance to turning. And that'll be like hand size, and it'll wrap around the original. This is the 35mm, which is the biggest that I'm using. You can see this is the lid for the NEX 5N barrel lens. So you have something like that big, and then you just design it per lens. Yeah, unfortunately, like I mentioned, these bottom rings aren't working, and then the 5mm, it's flipped. Like the aperture is on the bottom versus the top. It's not great. I also don't have a physical feedback like this one. It is labeled, see 1.8, 16, f16. I won't have that anymore with the ring thing. You could, but it would take longer to design. I'm not really that interested. What what I will do is just use the magnifying part. So yeah, I'll work on adding that into the design. I designed the body. Just gotta wait till morning to be able to start printing. I have to do some like dimensional checks before I commit, because each part is 8 and 5 hours. Like the front piece takes 8 hours, the back piece takes 5. So I gotta make sure they're ready to go before I commit. So also still have to design the little rotating things. You see I took the pegs out on the lenses. This 35mm, both the aperture and the zoom work, so it actually goes back and forth. These two, however, are not functional, like they don't go back and forth. I just have aperture control. However, I will still build the rotating rings. So yeah, and I did just, right now it's on, see the red light? That's that's a 10-axis IMU. It's crazy. I'm sorry. Just super overkill. I just couldn't remember if you needed the magnetometer to do dead reckoning. I mean, really all I want is tilt sensor, but I don't know if you need. But anyway, I also just tested everything still works, because I've been moving it around and my soldering is good. All the buttons work. Camera takes picture, which that's just connection. OLED still works, so yeah. So now I'm just designing the software, coming up with a menu system, the camera pass-through to the OLED. That part, I can get it to work, but the initial way I'm doing it is like really bad. It's very slow. But it's still cool to like make something from scratch. Greenfield development. You just have like a blank canvas and go any direction you want. Full speed to the wrong direction. I forgot to say that the reason I have it on right now is I'm doing a current draw test. I want to see how much battery it consumes in an hour. Granted, it's not a good test because like the camera isn't doing anything and it's not processing anything. But I'm also gonna desolder the battery, put a JST in there, so if the LiPo dies, it's not hard to swap it without, you know, desoldering, because everything will get bolted down. So I want to be able to easily change the battery if it dies. This is a single cell 720 milliamp hour, which is not that big. I'm expecting run times of like 3 hours at best, which should be plenty. I mean, that's continuously on. Normally you turn your camera on, walk around, or no, you walk around, you find somewhere you're going to take a picture of, turn it on, take your shots, turn it off, walk around. So that should be plenty. But there will be an internal database thing that keeps track of the time, and then it'll tell you. It'll also ask on boot if it was just charged, so it'll reset. So this is still super slow, but you can see the, like this is a real, and you can see it like, I can't focus it with one hand. In my right hand. It's focused right now, but I can make it unfocused. There. And then I'll focus it, turn the ring. Blurry, focus. Let's go, baby. Haven't printed in so long. Let's go. Pick it up, come on. Just doing a test fit. Monocle. Got the black filament. It's the only one I have. Test print looks good. That fits correctly. A lot of space. This, I think I'll bump up the bottom here. It's kind of a huge gap. Top looks alright. Yeah, I'll raise that bottom bit up. Ooh, that looks good. 10%, baby. 13. I was concerned it messed up. When it first started, there were some lines getting dragged around, but it looks good now. Damn. Not sure, but this could be the longest print I've done. It's 8 hours straight. Damn, look at it go. This printer is pretty damn good. Like, I've been able to just let it go. I did have to replace the hot end, but that was after like a couple years. But man, I'm looking forward to this. Let's see, it's 43%. Over long it's been 4 hours, dude. Shit. See how tiny those screw mounts are? They look huge in the modeling software over here. They're little nubs. Well, those are just supports though. We'll see. Damn. It's a freaking 87%. 7 hours. I'm just glad I didn't fail. I go 8 hours later. Took some old plastic off. Ooh. Man, I should have softened these edges. They're sharp. Holy crap. But you know what? It's alright. I did, I think. They're just not defined. Even the visible curve on the inside of the body is barely there with my finger. And the lip looks good. You see it? There. Ooh. That looks profesh. I gotta slice the other one. Get it printing. It's 5 hours. It's 5 o'clock. Let's have a look at this more. Lighting's not that great, but there's your IMU support. Okay, you can't see it. The Pi Zero mounts, let's see right there. The wall thickness around the screw hole is too thin. These might split when you screw into them. I'll have to see. Hole for the shutter, hole for the USB charger, screw holes for the camera mount, SD card hole. Seal screws to hold the parts together. It's really nice, and the front looks good. I mean, it's support connection, but it looks neat. Like, what a cool texture. Just wanted to go over this lens. All three of them are built like this. The largest one is 35mm. This is 5. So this one's like very wide. 12mm. Those are really wide, like full frame. But on this tiny size, it's actually like cropped. I don't know, I gotta check that out. But anyway, these initially Like until today we're stuck. See this dark part here? I don't know if that'll... That's supposed to slide in and out. So there's a thing here that says... Will this work? Come on. That looks better. This says open close. That's the aperture. Fully open. And you twist it. Small. It's a high number like F11. Lower number is super open. That's like lets in a lot of light. That's how you do like macro shots. And then we see this outer ring is zooming, or it's not zooming, it's focusing. And you can see it slide this dark thing, the inner, see it? Anyway, the point is, you design the outer ring things that are roughly the size of a normal lens, like what I'm filming with now. This is like a 2-inch diameter circle. So you design it to go around it, squeezes it, add like grip, and then you have full, control of this thing without it being like a tiny thing and using those little rotating things to lock it. It'll use friction to not move much. So yeah, I'll build those. Try to make them stylish, but I don't know. Let's see. Each one is different, unfortunately. See, they're all like different diameters. But it'll be worth it. Printing the other piece now. Oh, that's right, it is not flush. Whenever I see this, I'm like, oh, did it stop? Did it break? But no, it looks like it's still on track. It's at 38%. There it is. Sorry, it's poorly lit, but 5.5 hours. God, here we go. Does it fit? Oh my god. Oh, that's snug. Oh my god. Oh, I think it's 0. What's the tolerance? Actually, a little loose, but it's pretty damn good. Like, it wants to stay together. Oh my god. Oh, I made that. Wow. Look at it, it's real. It is. Boom. Let's get it in better light. Alright, so I should still be sleeping right now, but I woke up. So here we are. I would assemble this. I'm going to do one more idle current draw measurement where I plug a benchtop power supply to the battery. Then I'll run it just to see. I think it idles around 200 milliamps. That might be more if I'm displaying something on the OLED. I'll draw like a basic image and then I'll use that as a baseline. But you can see the halves and I already explained before, like the order that stuff will get attached in. This is not really intended to be taken apart often, so I will be using glue in some places. Like camera goes in first, IMU behind it, then the button gets glued in here because there are no screw holes. And then the this guy, the charger, will get glued here. I'm gonna put double-sided foam tape underneath it as like a heat transfer buffer, so it doesn't touch the plastic insulator. I mean, it'll just radiate heat on the other side. And then pie gets screwed into these top mounts, which I now realize these are probably too weak, but they're very long, so I'm hoping that'll make it strong. But the walls are thin. Like, I think once I screw into this, it's gonna split. That was a bad design, because when you plug stuff into the pie, that'll put force down and it'll try to rip it out of those mounts. That was a fail. Yeah, and I'll do the OLED, glue the D-pad down. That's tightly attached to the pie, so that won't be much room there. I might actually do the D-pad first, and then when you put it together, then you can screw the pie into it. So yeah, I'm gonna put this thing together, and then I'll start writing code, but I will design the lens grippers later. So I'm assembling this, and I should have flipped this IMU around. It still works, but it pushes against the ribbon cable. Then the other thing is the screws I'm using. The head is like too small, so it goes through the IMU holes, mounting holes. So I'm using a servo screw right here, hold it down. The other one is kind of just to prevent it from sliding around because the head fits in the hole. But yeah, that's not great. I mean, this isn't a huge deal. It's not like extremely accurate, and like the values are already have a lot of air. It's like a gimmick, but you know, it's there. So I'm just going through and attaching everything. It's pretty much there, but I just realized I didn't cut a hole out for the switch. Oh man. I'll just cut it manually for mine, but it'll modify the 3D files. 3D file, dang. Alright, another quick update. Sorry about the garbage everywhere. So, I had to burn a hole through to get the switch in. No, that's in. And then I initially had the pie screwed in first, but since this is so attached to that, I'll have to attach this to there first. I'm hoping I can do it like this. Flip it upwards. But it's getting there. Actually no, I'll do the OLED first, and then that'll put everything together more. Okay, so you can see the two halves. Batteries down there, it's very small. You can put a bigger one in there. Like one cell, but you know, maybe like 2,000 milliamp hour. Just check the dimensions. It pretty much has the entire flat area to fit it. And then the DC-DC just floats in there. There's pretty big clearance for it. There's a lot of empty space in here. Screwed the OLED in, glued the D-pad down. Now I'll just put them together and screw the pie in, and then put the outer screws in, and it'll be assembled. Oh my god, it's done. Let me get some light. One screw, one screw, one screw, one screw. OLED. You can see the red LED in there, it's on. Also see the pie indicator over there. left switches on, shutter, all these buttons. Charger works. I gotta verify everything still works wired after I put it together. My wiring inside with the soldering, the D-pad was too attached to the proto board GPIO header, so like this Pi wants to pull away from the attachment here, but the compression keeps it straight. See that SD card? So you just gotta make sure you leave enough room so the wires aren't too tight, or use thinner grouped wires. So yeah, I'll get better shots of it, not like on my desk. I have to print the rotating ring things that you attach to the lenses. See, I've got 3 of them. It's 35, 12, and 5mm. These are like Arducam. These 2 are Arducam. That one's so new. Some random thing I found on eBay, or not eBay, Amazon. Alright, I'll just be programming here from here on until the morning where I can print those rings. That'll complete the look, I think. Hopefully in a good way.